2 to 3 years, myself and some of the folks at Tarides and the broader OCaml community have been working on some extensions to Dune to enable it to do package management and to take over some of the tasks that were previously requiring OCaml to use instead. So let's give a quick background about the OCaml tooling that I'll be discussing today. So OCaml and Dune. So quick show of hands. Who here has used OCaml? Should basically all of us. Excellent. Okay, yeah, so this is, of course, the primary tool for installing OCaml packages. It also defines a metadata format for describing OCaml packages, and there's a repository of about 4,500 packages which you can install with OCaml. Now, Dune is a build system for building OCaml projects. About 3/4 of all of the packages on OCaml, the OCaml repository build with Dune currently. When we say that a package builds with Dune, this really means two different things. Like, first of all, when you install that package with OCaml, OCaml is going to use Dune to orchestrate the build of that package. But also, when you're developing a package with Dune, Dune is the primary tool that you'll use to do things like run your tests and build your code and run your examples. And until recently, in that second use case, which is going to be the primary focus of today's talk, in that second use case, you still needed to use OCaml to install all of your package's dependencies. However, this is now changed. It's now possible to use the Dune CLI to install all of your project's dependencies in the process of building them. And those packages still are described using the OCaml metadata format and are still stored in the OCaml repository. So you still have access to the full set of packages and all of the existing infrastructure for doing package management on the repository side. But now when you're developing a project, you can use Dune to install your dependencies as part of that development workflow. So the remainder of this talk is going to be a live demo where I show off some of these new features. So I'm going to make a OCaml project with Dune, add some dependencies to it, and use Dune to install those dependencies. And then also use Dune to install some tooling that we're going to use to make the development process a little bit easier. So drag this window across. Here's my terminal. How's this font size? Everyone can read these windows at the back? Very good. All right. So for starters, I'm just going to use OCaml to remove its switch from my shell. So this is going to mean that I have no OCaml compiler in my path, and that's going to be OK. So let's make a project. I think there's currently nothing here. Very good. So this Dune init project hello. This is an old command. We didn't add this as part of package management. All this does is it initializes a fresh project. We get a Dune project file. Even though this is a fresh project, it still has a single dependency on the OCaml compiler itself, which in the OCaml ecosystem, it's just an OCaml package. And the source code that we're going to be modifying today is this main, just ignore that error, main file, print hello world. So even though, as before, there's no OCaml compiler, that's OK, because I forgot a step. Actually nice that I forgot that step. In the very near future, that step's going to be automated. So what I had to do just then was the Dune package lock command, which you'll see in all of these slides, explicitly solves the dependency problem for your project and caches that solution in what we're calling a lock directory. I will go into that in a bit more detail later, but now that solution exists, I can run this command from before, and it's going to build all of my dependencies, downloading them if necessary, and then build the project using those dependencies. Dune has a cache, which I've warmed up before this talk, so we're not going to have to sit through the entire compiler compilation hopefully. This is taking a little bit longer than in my most recent test. And once this finishes, we'll see it print hello world. It's a little concerning that it's taking this long. Wow. I really hope it's not. Otherwise. Oh, sure. Yes, of course. We can use. So if you can resize also. I can, yes. How's that? That's very good. Can you multi-thread the compilation? Pardon? Can you multi-thread the compilation? Can I? Sorry, I didn't catch that word just saying. Did I? Multi-thread the compilation. Oh, I see. It is multi-threaded. This jobs here is the jobs that Dune has started, but one of those jobs is make-j on the compiler. Unfortunately, no. We would have to, you know. Oh man, I prepared for exactly this scenario, but this is the demo problem. Yeah. And then can we just like, oops. What is happening? I'm hesitant to kill this because it might mean we have to restart. Hey! Very good, and then there's a hello world after. I really hope that the other parts of this demo are cached correctly, because otherwise we could be in for a bit more of a wait. All right. Okay, so we can build the OCaml compiler, and we can use that to build our project, and that's all taken care of for us by Dune now. Let's add a dependency to our project. So we're going to make a little website using a framework called Dune. Called Dream. So the way that we add a dependency is editing the Dune editing a Dune project file. Here's our list of dependencies. We add Dream to this. And then we have to also remember to update a second file because that adds a dependency on the package. This adds a dependency on the library Dream. And so I'll do this just to demonstrate the problem. So we're going to get an error, and this is because now we've added a dependency. We have to solve our dependencies again. Once again, this is going to be automated quite soon. Let's do that. And so this is going to print out a list of all of the packages in the dependency closure for the project now that it's got an additional dependency. So here they all are. It's quite a lot. We see Dream is here. And yes. And now, so this is going to take about 20 seconds, hopefully. While we wait for this, I'll talk a little bit about what's going to change in the workflow very soon. Because as I mentioned before, this package lock command is no longer going to be necessary. When you run Dune build in the future, it's going to have the effect of locking, like solving your dependencies first, and then build with those dependencies afterwards. We're almost done. Of course, this isn't actually going to do anything. We haven't actually done anything with our dependency yet. We're still printing hello world. Okay. I think I understand why this isn't being cached. That'll come up later in the talk. I think while preparing for this, I may have left a setting on that has led to this problem. But if I turn it off now, we're going to have to rebuild this project again. So I think we'll just wait for it to build. It shouldn't take too much longer. We've got time for one question. Oh, please, yes. That would be great if anyone has a question. Yeah.
Earlier when you did the install, I noticed that it pulled in the Windows versions.
Yeah, that is the setting that I've left on. later in the talk, I'm going to talk about how actually, you know what? Let's take a quick look at our log files. So there's this directory. Hey, there it is. So there's this folder that got created when we solved the dependencies called Dune.log. And in that folder, there's a file for each package. And this is what we refer to as a log directory. And each of these files, so we'll look at Dreams. It contains all the information needed to build the package, and it also knows where the package's source is located so it can download the package, and also it knows all of the package's dependencies. And what we're seeing here is a prototype for a portable representation of this data. However, by default in Dune, this is not what you get. You get a version of this file that's specialized to your current computer, which is what I intended to show for this demo up until the very end, but here we are. So maybe I will, okay. I will adjust things slightly, but I'll do that later because it won't affect the demo up until a later point. So we just ran Dune. Sorry? How do I close this? Oh no, that's okay. Is it that? Yeah, okay. Dune exec hello. So we just run it again, it'll just print hello. And now let's use the new library that we've installed, Dream, to make a little website and show that off. So we can modify bin main. Now, I don't actually know the API for Dream. Wouldn't it be nice if there was some tooling to help us explore APIs from the libraries that we depend on? Of course there is, and I need it. So OCaml has an LSP server. It's called OCaml LSP server. And it needs to be compiled with the same compiler as is used to compile the code that it's analyzing. And since Dune is now responsible for installing your OCaml compiler, it also needs to be responsible for building your OCaml LSP server because it needs to make sure that it was compiled with the same compiler. And this is the point where I will switch back to the original representation of this because I need the cache version of this package or we'll be here all day. So there's a command called Dune tools install where you can give it the name of certain tools, like OCaml LSP, and it will have the effect of solving the dependencies for that tool with the same mechanisms as it uses to solve your dependencies. And then it will build and install the tool into your project's build directory. And this shouldn't take too much longer. If there's, okay, all right, cool. And so where did that install? So you can explore what's been installed like this. So we can see this, the OCaml LSP binary is now located at this path. This isn't super convenient for me using Vim. I need the OCaml LSP executable to be in my path, so Dune has an answer for that too. So there's a command Dune tools end, and it prints out this command, which adds some extra directories to your path, all of the bin directories for the different dev tools that Dune lets you install, even the ones that aren't currently installed, because we might install them later. So if I eval the output of that command, now when I type which OCaml LSP, it'll resolve to the one that I just installed. And while we're at it, so a Dune tool, let's install a second tool. Dune tools install OCaml format. The OCaml code formatter should be much faster to install, so we don't have to think about how to format our code. And when that finishes, see that it's already picking up the one from the dev tool because it was already added to our path. Yes. Okay, so back to our editing main. So we should now be able to type yeah, okay, run, yeah. Now, I'm not actually going to type a lookout out because we don't have time, so I'm just going to copy it from here. And let's confirm that we are, in fact, using LSP. Yeah, okay, so we have LSP in our editor now, thanks to installing it just before. And so here's a little Hello World website with Dream. Let's run that. And so this is going to start a web server that's going to let us do our site. Here it is, running at localhost 8080. Let's go there. Oh, looks like I'm already at 8080. Oh, there it is. Although unfortunately it's taken over my slides, so we'll just stop that. Fortunately, the other server is also still running, so I have my slides back. Now, wouldn't it be nice if we could change the port that web server is running on? And of course, Dream lets us specify the port the server runs on, but let's find a little more convoluted way to do it to demonstrate, and another feature in Dune, how to hack on the dependencies of your project in a fairly ergonomic way. So Dune has a feature called pinning. OCaml also has a similar feature of the same name. And this allows you to clone one of your dependencies, or clone as many as you want of your dependencies on your local machine, tell Dune to use that local version of the dependency rather than the one from the OCaml repo when building your project. And then you can make changes locally to that copy of the dependency and exercise the consequences of those changes in your project itself. So let's do this for Dream. So we're going to clone Dream. Clone Dream. Okay. And then, so somewhere in here, there's going to be some assignment to a variable. Yeah, okay, there it is. So let's just change that. HTTP, AT. Yeah, it's right there. Let's make it 8081. Cool. All right. We obviously didn't have LSP then because we're in a different project and we'd have to set it up with Dune, which we could do, but we don't have time today. And then back in Hello, we have to make one little change to our Dune project manifest. So this pin stanza. Oop, I don't want to know its definition. We'll copy this into our metadata, and the path to where I clone Dream uses as OCaml workshop Dream. And now we have to lock the project again because we changed its dependencies. And we'll see in the output of this when it prints the dependency closure that the version of Dream has changed to dev. You can specify what version you want here, but since this project depends on an arbitrary version of Dream, then that's the version that Dune has chosen by default in the absence of an explicit version number. And now when I run the web server again, we will hopefully see that it is running on port 8081. 8081, come on. Yes, 8081, there we go. And so now we can run it here without interfering with my slides. Very good. Okay, so let's take a closer look at how some of these features work internally. So I mentioned earlier that there's a lock directory, Dune.lock. And in addition to the Dune package lock command becoming automatic, we're also going to hide this directory away as an implementation detail in a future change. That might change again in the future once we're a bit more confident in its format, but we don't want to announce that Dune Package Management is finished with a metadata format that might change drastically in the future. So we can take a look at some of the files in this lock directory. So first of all, there's a metadata for your metadata. Edit that. This lock.dune file, which describes, I can make this a bit bigger now, describes the entire solution at a high level. So we can see the OCaml repositories that were used to generate this solution, so where all the packages come from. There's two. So this OPAM repository is the official OPAM repository, the one that you interact with when you use the OPAM command by default. This second one adds a couple of overlays. Oh, yes? Cool. Overlays for packages. So these are Dune package management specific modifications to packages as a temporary workaround for some minor incompatibilities between the way certain low-level packages build with OPAM versus with Dune. That may go away in the future. And we can also see here, so I mentioned earlier that these package solutions that Dune comes up with are specialized to your computer. I disabled the feature that made them general. And so here we see a set of variables. These are variables from the OPAM package manager that describe a platform. So your operating system, your architecture, all the different things that a package might want to specialize on. These are all listed here for debugging and reproducibility. And if we look at the log file for a specific package, so let's have a look at Dreams. I showed this off a bit earlier. This is the non-portable version of this file, so all of the platform conditional parts have been removed. So all we have here is how to build the package, the dependencies of the package, and where to download the package from. So from this lock directory alone, there's enough information to completely instantiate all of your project's dependencies and build them and then build your project with them. So if you have this lock directory, you don't need to do a solve. And in fact, you can remove all of the OPAM repository data from your computer, as all the relevant parts of it are now just here in the lock directory. So there are some limitations here. The lock directories. I need to mention that. So the reason why, an obvious question when seeing this solution, one might ask, why is it a directory and not a file? Most other ecosystems use log files. We chose to go with directories instead because when you're changing the dependencies of a project or updating the dependencies of a project, it's quite useful if you can see the diff and understand the consequences of those changes. It's very bad if you get these surprise additions to your software bill of material without having. So to make it not a surprise, we thought that it would be easier to be able to review these changes. If every package has its own its own unique file in the lock directory that you can view the diff of without having that be mugged with the diffs of other packages. So current as I said before, currently these are specialized to your computer. So it does complicate the story a little bit if you're planning to check these into version control, as it'll mean that people on other computers that have different architecture or operating system might get unexpected results when using your log file. There's a mechanism in Dune to generate multiple different log files per platform. I'm not going to show it up here, and it's not sure. We're not sure whether or not this is the right solution. An alternative, which I accidentally showed off earlier, is this idea of portable log directories, where I think since I showed it off before, I won't take the time to go into it now. But each of these platform-specific sections are annotated with a conditional that says on which platforms they should be used. And this allows you to generate log directories. It also allows you to generate log directories which contain packages for other architectures than your own. So you saw initially the solution contained some Windows-specific packages, like the MingW packages. And that would have meant that I could check that log directory into version control, clone it on a Windows machine, say, build it, and there's a chance that it will work. Obviously, I haven't tested it. I don't know for sure. But all the dependencies theoretically will be there, and it has the potential to work, even if that can't be guaranteed, without an actual Windows machine present. And finally, where do these packages get installed to? So instead of an OPAM switch, inside of your build directory, there's now this directory. This is all an implementation detail, by the way. It might change in the future. But we have this folder full of per package subfolders with a name, a version, and a hash. If you've used NixOS, this sort of thing might be familiar to you. If we zoom in on one of these, let's look at dream.dev. There's a source directory, which looks identical to the Dream source directory. In fact, it is identical to the Dream source directory. And there's a second directory, it's just a copy of it. And the target directory, which might look familiar to you if you've ever peeked inside of an OCaml switch. These are the compiled artifacts that are built from the package. I don't believe we will have time to go into this. There's a mechanism for telling telling Dune where to look to solve your project dependencies rather than using the default OCaml repository. And there's a way to leverage that mechanism to get a lightweight lock file in just the form of freezing those repositories in place. I won't go into that in too much detail, but if you're curious, ask me later. And so in its current state, Dune Package Management works as I've demonstrated here. There's a small usability change to automate generating the solution, which will be released in the next month or so. After which point, expect an announcement. After which point, expect an announcement of the form that Dune Package Management is now encouraged for daily use. However, we won't be done yet. At that point, there's plenty more work to do on Dune Package Management. So there is a handful of packages in the OCaml repository that currently can't be built with Dune, including Dune itself, due to an issue where packages can have what I'm going to call a benign circular dependency, where, for example, one of your tests, in Dune's case, one of the packages it uses for testing, ppx expect, and several other packages, build with Dune themselves, which creates a circular dependency which shouldn't be an issue and isn't in OCaml, but due to some implementation details, currently that's not possible in Dune. Currently, Dune Package Management only works on Linux and Mac OS. At some point, we'll add Windows support. Adding additional features to make it possible to manage the life cycle of a package, such as automatically building all of the reverse dependencies of a package and testing your local changes in the context of those reverse dependencies, similar to the pin example I gave earlier, but kind of inverted. And making it easy to install Dune. Currently, the recommended way to install Dune is with OCaml. There's an experimental binary installer, but it's not really ready for prime time yet. And at some point, it'd be really nice if we could add packages to the popular system package managers like Aptitude and Brew, so that you can just install Dune on a fresh computer without an OCaml installation on it and just get started working on OCaml right away. And finally, adopting more features from OCaml to better support truly Dune-only workflow for OCaml development, such as like searching for a package by its name. All right, that's all I've prepared, so thanks everyone.
Any questions?
Hi, thank you for that. And I have a question related to watch mode and the pinned packages. Will it track the changes in pinned packages in watch mode? Because it's like super useful.
That would be super useful. I honestly don't know. If there's no more, we can try it out later and see.
Okay.
Yeah.
Thank you.
Hi. One of the things that could be useful in comparison to OCaml is Dune could theoretically discover what packages it needs based on what's in the libraries field of all of your targets. Is that something that is planned, or is that something that could work?
There's not a concrete plan for, it's a known problem, I agree. We don't have a super clear solution to that yet. The complication comes from the fact that the namespaces of libraries aren't really like stored anywhere, right? So the only way to find out would be to do some sort of scan of the OCaml repository to see what libraries are defined and build some sort of reverse table that maps libraries back to packages that they contain, and then have some plan for dealing with the collisions that might allow.
Okay, so yeah.
Hi, thanks for the talk. I'm curious what the performance regressions were that we saw at the start of the talk when you enabled this portable log file feature.
So that would have been because the let me see if I can figure it out. So it would have been installing the compiler. And the question is, why did it need to rebuild the compiler? So Dune has a cache, and it caches the output, the result of building packages. And the keys to that cache are quite fine-grained. I guess it's really, really important that we never get a false positive and accidentally retrieve a value from the cache. The cache spans multiple projects, right? And so it'd be really bad if something built in one project is manifested in another project that isn't guaranteed to be compatible. It may be a case that part of that key is overly conservative and led to a cache miss that was unnecessary, because the compiler that was in the solution would have been the same version of the compiler as the one. It wouldn't have mattered between a portable and a non-portable lock directory, right? So, yeah, it's a good question. I don't have a super clear answer for you. It'd be interesting to look into it deeper, but it'd be something to do with cache keying and getting an unnecessary cache.
Right. That makes sense. I have one more question. Do I have time? The benign circular dependencies, I'm wondering what is the issue there? Because I'm aware of the post flag in OPAM, which allows you to break cyclic dependencies, but it seems like it's an issue with the variables of a package, like the test dependencies.
So if you have a workspace, like a project in Dune, and that project can have multiple different packages in it, and normally it's okay for packages to depend on one another within a workspace. Like you can easily, like Dune does this obviously, like it defines, say, like standard Dune and Dune, which depends on standard Dune. That's fine. The problem comes up when that dependency goes via an external dependency. So if your package solution contains some package which then depends back on, A from your project depends on B from external, which depends on C from your project. There's something fundamentally untenable about this. It's just an implementation detail in Dune where it's a bit too coarse in the sort of internal way that it represents dependencies.
Right.
Which means that benign case, Dune can't detect that as benign, and it just believes that it's a true circular, a malign circular dependency, I guess.
Right. That makes sense. Thank you.
One more? Yeah.
Should be quick. Have you thought about integrating this with the docs generation so that you could get a nice sort of solution for all of the documentation for the specific packages that you're using for this project?
That's interesting. No, we haven't. But yeah, I know that Cargo has a way of doing that, right? Where you can say cargo doc and get a nice little website. That'd be cool. There is a tool. You saw the OCaml LSP example where we installed OCaml LSP. You can do the same thing with ODoc. So you can install the tools necessary to do that, but I don't think there's a way, and you can run it on your own project, but I don't think there's a way to run it on your dependencies, but that would be super cool.
Cool.
First of all, really brave doing the live demo. I really enjoyed it. We often, whenever I do this sort of thing, I check in all the source code into a monorepo, so in Docker and in real world OCaml and things. We just have all of it checked in so we can make changes locally and then push them out to all the different repositories. And also the CI doesn't need to have any kind of local network access, so it just does a Dune build. I'm curious what the direction of travel here is. So we have relocatable compiler patches now for OCaml. So do you think that we should be moving towards checking in our source code, like Go does, for example? Or should we always be resolving these log files and trying to do this, and including building the compiler using Dune Package Management?
Yeah, that's an interesting question. So checking in the source code of all of your dependencies. You mean?
Yeah, so real world OCaml, we just literally untar the source code into a Duneverse directory and then do a Dune build, and Dune picks up all of the individual constituent libraries. And we have overlays for if they can't be built with Dune by default.
Yeah, sure. And I mean, I think that workflow is supported. I'm not sure if it's the one that we recommend first, just because it seems like checking in a lot of code that would be like duplicated from some other source, right? Like the lock directories contain like hashes of the tables of the source, right? So you get a guarantee that it's what you expect. I guess the only reason for checking in the source would be to avoid the need to download it later on from some other source. So I guess one extra value of doing it that way is that the OCaml repository has the property that package's source code is not stored in the repository itself. There's just a URL pointing to an arbitrary location, which historically have been prone to going down when they're not just like GitHub. So that would be a way to give more. So yeah, there's lots of value in a solution like that.
Sounds good. No, thanks very much. That sounds good.
All right, let's thank our speaker again.